Good morning, fourth graders. We are on day 2 of week 1, looking in the instructional book, page 252 through 253. Remember, your instructional book looks like this bad boy right here. Jumping right into it, you need to get your math journal out and a pencil. You should already have a pencil. Let's look. We have U.S. customary units of weight and mass today. Yesterday, we were talking a lot about the distance, the lengths. Today we're going to talk about weight and mass, and we're not going to talk about metric right now. We're going to talk about U.S. customary. This is what we use in the United States. So from smallest to largest, we start with ounces, abbreviation OZ, pounds, abbreviation LBS, tons with the abbreviation of 1 capital T. All right, and what this is going to look conversion-wise is 1 pound is equivalent to 16 ounces. So if I had a pound of cheese, I could also say that I had 16 ounces of cheese. 1 ton is equivalent to 32,000 ounces. So if I had 1 ton, a block of cheese that weighed a ton, it would weigh 32,000 ounces. And then 1 ton is also equivalent to 2,000 pounds. Make sure you get your math journal out. Make sure you're writing this down. You're going to want it for later when we get into the practice book. Now, let's look at ounces and pounds as a conversion chart. So we know that 1 pound is equivalent to 16 ounces. But what about 2 pounds? What formula or equation would you use to finish this table? Remember our rules though. If we go from big to small, we what? We multiply. So we have 2 pounds here. Let's look at that. So if we were to do this, 1 pound times 16, because that's how many ounces are in a pound, equals what? 16 ounces. So 2 pounds, and we're going to multiply because we're going from a big unit of measurement to a smaller unit of measurement. We're going to do 2 times 16 because 16 is how many pounds are in, or how many ounces are in a pound, excuse me. So 2 times 16, we have 2 times 6 is 12. We have that 1 up here. 2 times 1 is 2, plus that 1 is 3. So in 2 pounds, there are 32 ounces. Bam, 32 ounces. Can you finish the rest of the table? I'll give you a minute. Pause the video, see if you can get this right. Okay, so you should have paused the video and you should have used that same equation to figure out how many ounces are in 3 pounds. How many ounces are in 4 pounds, and how many ounces are in 5 pounds. Let's look. So if we were wanting to find out 3 pounds, so I have 3 pounds of cheese. Well, how many ounces of cheese do I have? I'm going to multiply 3 times 16, because 16 ounces are in a pound. 3 times 6 is what? 3 times 6 is 18. Carry the 1, 3 times 1 is 1, or 3 times 1 is 3, plus that 1, we have 48. You can also look at it as a bar model. Let me grab my board. It's easier to show you this way. So if we want to look at it as a bar model, all right, we have 4 groups, 4 pounds. So it's going to look like this. 1, 2, 3, 4. All right. How many ounces are in each pound? 16. So within each group, we have 16. And you can look at this as 16 times 4. Or you can look at it as repeated addition and say 16 plus 16 plus 16 plus 16 equals what? 64. showing it as a multiplication problem. 6 times 4 is 24. Carry our 2. 4 times 1 is 4. Add in our 2. 64. And then finally we have 5 pounds is the same as saying 80 ounces. Good job, guys. Make sure you have that written in your journal, okay? All right, let's go right into the book. This is going to be a little different today because I was having issues with some technology yesterday morning, going back and forth between my computer screen and the easel. I accidentally cut off the whole easel, and I didn't mean to do that. And so I'm going to read and kind of talk about it, and then we're going to look at the questions to the side. All right? So, Wanda is shopping for a pet carrier for her cat. One small carrier can hold 240 ounces. Her cat weighs 12 pounds. Can the carrier hold her cat? So, where did the board go? Here we are. It does give you the example on page 252. That's what I'm on, page 252, the instructional book. And it does give you the chart. It's actually very similar to the chart that we just did. All right, so the question is asking us if her cat, or if the cat carrier can actually hold her cat. How much did the cat weigh? The cat weighed 12 pounds. 12 pounds. Remember your abbreviation. You need to make sure you're writing the unit of measurement that you're looking at, or people won't really know what you're talking about. All right, and the cat carrier says it can hold 240 ounces. Okay? Now, what it's asking us to do is to find out whether or not the cat carrier that can hold 240 ounces will fit her cat. So we need to convert the cat's weight from pounds to ounces in order to make a good comparison. Because remember, we can't really compare unless the unit of measurement is the same. Think back to yesterday's lesson with time. We can't compare minutes to seconds because they're different units of time. We have to convert those minutes into seconds in order for it to make sense. So, going back to our formula, we have 1 times 16, because that's how many ounces are in a pound. We have 12 pounds here, so we're going to replace that 1 with 12, and we're going to multiply it by what? How many pounds or how many ounces are in a pound? 16. So we're going to multiply. Now, this is a two-digit or double-digit, multi-digit multiplication problem. So if you have problems with these, remember our area model. The area model, the big square, we broke up our numbers into expanded form. So 12 would look like 10 plus 2. And 16 would look like 10 plus 6. And then we just multiply through. 10 times 10, 10 times 2, 6 times 10, and 6 times 2. Go through and get our partial products. 10 times 10 is 100. 10 times 2 is 20. 6 times 10 is 60. And 6 times 2 is 12. And then you just go through and add. We have 100, 7, 8 tens, and, nope, we have 9 tens. My bad. 9 tens and 2 ones. Let me fix that. Boop. Or you can do it as the standard algorithm. 6 times 2 is 12. Carry the 1. 6 times 1 is 6. Plus that 1 is 7. Put your placeholder. 1 times 2 is 2. 1 times 1 is 1. And we add it this way. 7, 8, 9, 192. Same answer, just different strategies. All right, so her cat weighs 192 pounds. You can pause the video if you need to write this down, but I'm going to go ahead and erase so I can move on. So we had 192 ounces is how much that cat's going to weigh. The cat carrier said that it can carry 240 ounces. So the question was, can the carrier hold her cat? Can it? Which number is bigger? This one. the cat carrier, the carrier can hold more, or can hold how much the cat weighs, because the cat only weighs 192 ounces. All right. Moving on, so you can go through on page 252, really look at the model it. You can even copy that model down. You can go further. We only went up to 5. It looks like the model on here went all the way up to 12. So you can either do that, or you can just use our table, because we, as long as we know how many pounds are, or how many ounces are in a pound, you can create that formula with anything. If I said, I had a dog, he weighed 82 pounds. All right, my dog carrier can only hold 300 ounces. All right, all I would have to do is take that 80, multiply it by 16, and I can find out how much, or whether or not my dog carrier will fit it. All right, looking at number 2, okay, that just kind of went through everything that we did. So from what we were talking about, we should be able to get through 2 through 6. I'll just go through the answers real quick for you. Number 2 should have been 16 ounces, because the bar model shows that 1 pound is equal to 16 ounces. Number 3, what do you multiply the number of pounds by to find the number of ounces? Well, we know we multiply it by 16, because there are 16 ounces in 1 pound. We wrote our expression. Number 4 should have been P times 16. They did give you a variable there for P. We just kind of just put 1. Number 5, use the expression to solve the problem from the previous page. Can the cat carrier hold the cat? So number 5 is where you're going to put whether or not the cat could fit in the carrier, which we agreed that the cat could fit, because the cat was only 192 ounces and the cat carrier could hold 240 ounces. All right, let's look at number 7, all the way down in the reflection spot. We're going to skip that one, so that would mess up. Here we go. All right. Number 7 says Steve buys 14 ounces of kiwis. All right, 14 ounces, that's important. I'm just going to box that in. And 2 pounds of peaches. That's important. How many more ounces do the peaches weigh than the kiwis? So here's our question. We're just going to circle our question, because this is what it's wanting us to answer. Now, there's a couple ways we can go about this, and this is a multi-step problem, meaning we're going to have to do more than one math equation in order to solve this. What do you think we're going to have to do first? Well, we have 14 ounces of kiwis and 2 pounds of peaches. Are those units of measurement the same? No, they're different. We're looking at ounces and pounds. So our first step is going to be converting that 2 pounds to ounces. That way we can be looking at the same unit of measurement, and we can make a decent comparison. So we have 2 pounds. What am I going to do? That's right. I'm going to use the formula that we used before. Remember that 1 pound is equal to 16 ounces. Well, here we have 2 pounds. And we're going to multiply, because we're going from a large unit to a small unit. So we're multiplying. And we're going to multiply it by however many ounces are in a single pound. So we're going to multiply it by 16. Well, 2 times 16, or you could even look back at our conversion table. Oh. Let me see if I can do it. Oh. There we go. 2 pounds is the same as 32 ounces. So I didn't even really have to do any math, because I wrote my table down. Awesome. So we have 32 ounces. Now, that's our first step. Our second step to this problem, is we need to answer this question. We need to find out how many more ounces do the peaches weigh than the kiwis. So our kiwis were 14 ounces. 14 ounces. And it says how many more ounces. So I'm going to subtract. I'm going to subtract from the 32 ounces, because remember, the 32 ounces is how much we had in peaches. So 32 minus 14 is what? I'll give you a second to do the math. You do the math. Don't make me do all this math by myself. All right, 32 minus 14, it should have been 18 ounces. If you didn't get that, you might have carried wrong. So let's look at it as in the standard algorithm. 32 minus 14. Remember, we can't take 2 from 4. If I had $2, I can't give you $4. So we're going to borrow. We're going to cross off that 3. We're going to make it a 2, and we're going to borrow that 10. Now we have 12 minus 4. 12 minus 4 is 8. 2 minus 1 is 1. All right, real quick. Next one, number 8. I'm just going to change colors because I like colorful charts. I'm sure y'all seen it in the library of anchor charts that I posted on Facebook. An empty suitcase has a mass of 2 kilograms. Draw a bar model to find its mass in grams. And then it gives us the key. 1 kilogram, this is kind of messy. In your book it looks a lot better. 1 kilogram equals 1,000 grams. So we're going to put up, hang on one second, guys. I've got to answer the phone. Sorry about that, I had to answer the phone. So we have an empty suitcase has a mass of 2 kilograms. It wants us to draw a bar model to find its mass in grams. It gives us the key, 1 kilogram equals 1,000 grams. I'm going to go through, I'm going to really quickly code my word problem. I've got 2 kilograms. This is what it's asking me to do. Beautiful, and this is important because it is my key. So I'm going to go through, I'm going to change markers because that one's not wanting to work very well. I wonder if pink will show. Okay. We're going to draw a bar model. So we're going to start with a rectangle. Here we go. We want to label our bar model. So we have kilograms to grams. And we're just going to use the abbreviation for it. Bam. It already tells us that 1 kilogram equals 1,000 grams. We want to know, because we have this empty suitcase that has a mass of 2 kilograms, well, how much is 2 kilograms in terms of grams? Well, we're going from a big unit to a small unit, so what operation are we going to use? We're going to multiply. So we already know, that 1 kilogram is the same as 1,000 grams. So I'm going to replace that 1 with a 2, and I'm going to multiply it by what? 1,000, because that's how many grams are in each of these pounds. Or not pounds, kilograms. Excuse me. So when we do 2 times 1,000, we have 2 times 1 is 2. And then how many zeros do we have? We have 3. Boom. Just that easy, guys. It's not that easy. Conversions were hard for me in school, and so it takes some time and it takes some practice, and you have to be patient with yourself. I would 100% recommend going back to the YouTube videos that I posted yesterday, or technically this morning. The different songs, I know you guys like those rock songs. So I found a couple that had to do with this that might help you guys out. So I strongly recommend that you use that. Also, what will help you is if you have IXL. My students that are signed in on IXL, you can get a lot of practice with this on IXL. Just go through and drop to the drop-down menu and go to measurement, and then just work in all the conversion practices that they have. Or even if you're not IXL, Khan Academy has a lot too. And I'll post those links to this video. All right, so we've done our instructional book. We're going to move on to our practice book, page 251 through 252. Remember your practice book? I had one over here. Biscuits and gravy. Here it is. Practice book. This is what we're in now. And we're looking at number 1. Do I want to do this on here? We're gonna do this on the screen. Yeah, we'll do this on the screen. So let's yeah, we'll do this on the screen. All right, I'm gonna pop back on, but I'm gonna share my computer screen with you guys so we can move along together, and I'll use the whiteboard on the computer. Alrighty, I'll be back.